Hello students, welcome once again back to a course on mass transfer 1. So you all know that we are in the process of understanding the drying operation under the unit number 6 of the course, and having completed the first two sessions, let us see what we are supposed to learn in today's session. So in the last session we learned about the various properties of air water vapor system. Then we also learned the equilibrium relationship in drying operation. So in today's class, we need to understand what is meant by the rate of batch drying, and how to conduct a drying test, and what is the purpose of conducting drying test for a given sample. Then also we have to learn the characteristics of wet solids with the help of results obtained in a drying test. And in that part, we are going to study the nature of different types of drying curves. Okay, so let us now understand what is the purpose of conducting a drying test. So, a knowledge of time required for drying of a substance from one particular level of moisture content to another level under specified drying conditions is needed for determining the size of the dryer and also for setting up drying schedules. So, whenever you have to conduct a drying operation, so you need to design a suitable dryer and also should set up drying schedules. So, this is the reason why a drying test is carried out in a model dryer similar to the type of dryer that is to be designed, and the time required for drying is measured, and with that we can deduce other things that are required to construct a suitable dryer. Okay, so in this instance, uh, when a dry substance is obtained from a particular type of dryer, so we also need to know the effect of different drying conditions upon the time needed for drying. So, at what condition the time required is less and at what condition it is more. So, this knowledge is also important for the above said purpose. So, for that purpose, we need to run a drying test of a material that is in question, means the one which is to be dried at the given condition, given situation. We need to construct a model dryer. So similar to the type of dryer that is need to be designed and installed. So conducting the test and measuring the rates of batch drying is relatively simple, and thus provides the information useful for batches as well as continuous drying operations. Okay, so this batch drying test is relatively easy to conduct, and it provides the necessary information can be used for batch operation as well as continuous drying operation. So what we exactly do in a drying test? So to do a drying test mainly involves the determination of rate of drying, and for that purpose we need to keep a sample of the given material spread uniformly over a tray of uniform thickness, and that tray will be suspended from a weighing balance in a cabinet. So this is a kind of setup what we require to conduct batch drying test. The bottom and edges of the tray should be well insulated, and then we have to blow air over the surface of the wet material. So after keeping the tray with the uniformly spread the sample of wet material, we need to close the cabinet tightly. Then we need to blow the air over the surface of the wet material. So also we need to maintain a constant drying condition inside the model dryer. So that's done by keeping the velocity of the air that is blown over the material to be constant, and also we need to maintain a constant temperature and humidity of air. So then we have to measure the weight of the sample as a function of time. So for this purpose, uh, we will keep one of the that is tray on one side of the balance and the weights on the other side of the balance, so that the balance comes to a steady position. So then if you remove 1 gram of weight from one side, the balance tilts towards the side of the sample, and then we need to switch on the stopwatch, and continuous blowing of air is maintained, and the time required to dry 1 gram of material is noted down when the balance gets to the position of steady state, and the time required will be noted down. So in that way, we can go on drying 1 gram each time, and the time required using a stopwatch is noted down. So then the drying characteristics of the given wet solids will be described by the drying rate curves obtained under the constant drying conditions. So after conducting this test, the graphs as shown in figures are constructed. So the two curves can be constructed from the obtained results, that is moisture content versus time as shown in figure A, and the drying rate versus moisture content that is shown in figure B. So generally, the experimental evaluation of the curves of these curves is done before performing drying calculations. So that is the idea or the objective of conducting a drying test. So after plotting these curves, one is a moisture content versus time, other one is rate versus time. So we need to analyze these curves experimentally before performing calculations required to design a particular drying equipment. So consider that wet solids with an initial moisture content X1. So this is the initial moisture content are exposed to air of constant temperature and humidity. Then if we measure the moisture content as a function of time, that is moisture content of the material is measured at various values of time, then a curve such as the one shown in figure A, so this is a figure A, it's supposed to be, is obtained from the collected data. So this is the kind of curve that we can obtain in general. So when you plot moisture content versus time, the curve relates the moisture content on a dry basis with time. From what you can make out from the curve. So now it's clear from the curve that moisture content of the solids decrease with time, and after some time it remains constant at x star, which is the equilibrium moisture content. Okay, so this is your initial moisture content. So as indicated by the curve, so we can make out that the moisture content has decreased with the time and finally becoming constant at particular time, and that constant value of moisture is the equilibrium moisture content x star. So from curve of figure A, we can draw another type of curve which is known as the rate of drying curve, and that is shown in figure C. So this is the one which is more descriptive of the drying process. So it is obtained by measuring the slope of the tangents drawn to the curve as shown in figure A. So and the slopes are used to calculate the rate of drying at each moisture content value, and then that rate calculated will be plotted against the moisture content to get this kind of curve. Okay, so that is what is explained here. The rate of drying curve gives the relationship between rate of drying expressed as moisture evaporated per unit time per unit area of the drying surface, the and the moisture content on dry basis. The curve can be constructed by measuring the slopes of tangents drawn to the curve of figure A at various values of the moisture content and then calculating rate as n equals minus ss dx by dt into 1 by A. Okay, this is the formula that can be used to calculate the rate of drying at various values of moisture content. Okay, so n represents the rate of drying, or you can also use capital R to represent rate of drying. Then minus ss is the weight of dry solids. So dx by dt is that result obtained from the conducting of the drying test. So that is measuring the moisture with respect to time. So dx by dt at various values of moisture content is obtained. So that into dry weight of solid into 1 divided by area of drying surface. So this gives the rate, which is very essential and should be carefully done in the given situation. So as this is the weight of dry solids, A is the area of the drying surface. Okay. So let us now understand the rate of drying curve and how it changes its shape, showing the different kinds of variation of rate of drying with respect to moisture content. Section AB of the curve represents warming up period during which the temperature of the solid is becoming equal to the temperature of the drying air. So the first segment of the curve is the line AB. So this portion is called as a warming up period. So warming up period means it is that part of the drying process. So initially it takes place for a shorter period, and this is where the temperature of the solid is becoming equal to the temperature of the drying medium. Okay. So once that period is over, for certain period of operation, the rate of drying remains constant. So that part of the drying rate curve is called constant rate period, as shown by the segment BC. Okay. So from B to C, the curve is straight line parallel to its axis representing the constant rate of drying. Thus, the straight line BC is called the constant rate period, during which a layer of solid water on the surface of solid is being evaporated. So from B to C, you can see the curve is a straight line and also it is parallel to x-axis, showing that over this period the rate of drying remains constant with respect to time. Okay. So what happens during this period is a portion of solvent or moisture present from the surface of the material actually gets removed during this particular period of operation. The rate of drying is constant from B to C, so that is already understood, as the drying takes place from a saturated surface. So saturated surface means if the surface is containing moisture or presence of moisture is absorbed on the surface, which is uniform throughout the entire surface. So that is called saturated surface. The section CE of the curve represents the falling rate period composed of two periods. One is the first falling rate period, other one is second falling rate period. The rate of drying is constant from B to C as the drying takes place from the saturated surface. Okay. So the section CE of the curve represents the falling rate period composed of The first falling rate period shown by CD and the second falling rate period shown by DE. The section CD of the curve represents the period corresponding to the zone of unsaturated surface dry. The moisture content at which the constant rate period ends and at which the falling rate period starts is known as critical moisture content. Okay, so this is the critical moisture content for the given operation. It is usually denoted by XC. After point D, the surface of the solid is completely dry. Now, internal movement of moisture starts coming to surface. This is continued up to point E, where the equilibrium is attained, is reached. Okay. So this is the period over which the evaporation takes place from the unsaturated surface. So that is the reason why the section CD is a constant, is a straight line. I'm sorry. The rate of drying over section DE is governed by the rate of internal moisture movement. Okay, so let us now understand the factors on which the rate of drying depends upon. So one is the velocity of the gas. When the velocity of the gas or air is high, the rate of drying will also be high. Also humidity. Lesser the humidity, the more will be the rate of drying. Area of drying surface. If the area of the wet surface is exposed to the gas or air is more, then the rate of drying will also be more. Temperature. If the temperature of the gas is increased, its relative humidity decreases and thus increases the driving force, and a concentration difference of the moisture between the solid and gas, and so the rate of drying increases. Okay, diagram showing you how she has been showing you the rate of drying curve, also percentage moisture content of the product, and how the product temperature varies with time. All this has been shown in this diagram. Okay, so another diagram showing you the rate of drying curves. Okay, so do watch these videos, the links of which I have provided you. So these are really helpful in understanding the concepts. Please do make use of them. So this is a quick recap of the today's class discussions. So we learnt about rate of batch drying and drying test. So drying characteristics of wet solids. So that is also we have learnt in today's class. Then rate of drying curves. So, so with that, let me take leave. So before that, let me take you to a set of multiple choice questions. In the constant rate period, the rate of drying curve for batch drying, cracks develop on the surface of the solid. Rate of drying decreases abruptly. Surface phenomena separation of unbound moisture occurs. So what do you think is the right? Okay, right answer is C. In constant rate of drying for batch drying, surface evaporation of unbound moisture occurs. The falling rate period in the drying of a solid is characterized by increase in rate of drying, increase in temperature both on the surface and within the solid. So with that, let me complete the class today. See you again in the next class to learn about the estimation of the time required for drying. Sorry. So thank you. See you again in the